Ladies and gentlemen, dear students, welcome everyone to this extraordinary GameLab session today. I'm the humble host. My name is Sebastian. I'm running the show in the GameLab usually, together with my employees. And today we are honored to welcome ForestRingGames in our midst, and they will be presenting about their quite successful start and journey into economy, into the free market, starting from the university grounds as well. And before I pass on the microphone, I wanted to invite all of you, the students anyways, but also our audience on Twitch, to attend our Twitch stream of the GameLab presentations on the 4th of February. It's also going to start at noon, and we will iterate through the GameLab 1, 2, and 3 projects, and maybe some other game engineering projects that are running at our university as well. The timeline is still open, the schedule is still a bit open, but we are going to start at noon, just as today. And one word about this towards the students: the 3 best projects that are going to be presented at the Twitch stream session beginning of February are going to be selected for a pitch presentation at Düsseldorf Ubisoft quarters for further action, let's say. Okay, so we are going to have hopefully a lot of well-versed and well-informed people in the audience on the Twitch channel beginning of February as well, just as I hope the audience on Twitch is also present today. And with that, no further ado, and I'll pass on word to Max. And again, thank you very much for coming, and a big hand already from the audience at this point. Thank you.
Thanks. Hello, I'm Max from ForestRingGames. We are a young mobile game development company from Würzburg. Our origins are in fact at this university here, and I wrote my master thesis here and developed the prototype of our first game, TowerDuel, here as well. Today we are going to discuss the development of competitive, real-time multiplayer mobile games. And if you have any questions, please ask them at any time and interrupt me. I'd like to keep it as interactive as possible. So, about the games we are developing. We are thriving to unite the core user from console and PC platforms with the mobile users that are more casual audiences. And our mission is to build games that you don't have to be serious about, but you can be. So in the sense of our first game, TowerDuel, that means you can develop tactics and strategies and read up of all the different things online and discuss with your friends and try to be an esport player and play online. Or you can just play a few games casually with your friends. And both worlds are possible, and everything in the spectrum of that as well. We are a team of 8 people, and the special thing about us is that we are working completely remote. So our graphics designer, for example, comes from Latvia, while our audio designer is from the US. And we are communicating via the more classic team chat platforms like Slack, but we are also using Discord for voice chat and to stay in touch with our community that give us constant feedback and help us finding issues in the game, and also give a lot of new ideas into the game, how we can improve for the future. Now on to TowerDuel. First of all, I'm going to show a trailer video. Okay, so as you can see, TowerDuel is a tower defense game that you play online against other players, and you defend and attack at the same times. It's inspired by one of the most classic games that we have, like Warcraft 3, where lots of fun maps came from and lots of different game modes from today's most popular games came from. And we used the fun map Line Tower Wars, and the basic game principle originated from here. But not only TowerDuel comes from popular fun maps from Warcraft 3, there's also Dota, which now has a lot of standalone games that are based on that game mode. And we took it upon us to adapt the Line Tower Wars game mode and make like the spiritual successor to this game, adapt it for mobile, and make the controls work and the game feel more modern, so people can play it again. So about TowerDuel, we released it early last year. We already reached the top 50 of the strategy game genre in 13 countries, and we've been featured by Apple 3 times. And we invite all of you to get the game from the app stores, download it, try it out, give us some feedback, and of course leave us a great review there, so we are going up the ranks once again. So the game is player versus player online real time. You can play on iOS versus Android. It features ELO matchmaking, which means that you are matched against players of equal skill rating. And if you are winning a lot, you are going up in the leagues. Trying to reach the upper leagues is then more towards the esports side of the game, while the lower to medium leagues are more for casual players, and you are slowly improving there. Game features countless maps and different variations. The further you league up, the more difficult and interesting maps appear there. So there's a constant progress of players unlocking new content. You can check out replays of your matches that you play to analyze your mistakes, and of course to also see how awesome you've played in the last match. And we are featuring a unique level up system in the game. That means if you improve your cards, which are your towers and your runners in the game, you can always decide in which ways you want to improve them. So if you improve a tower, you can decide, for example, if you wanted to have a better range or to deal more damage. And this way players are customizing their towers and their runners throughout their playthrough of the game. And in the end, everybody has a totally customized deck, and there are millions of possibilities how your deck and your cards can end up in the end. So the defense side, on your stadium half, you are building defenses, you are building towers. There are 12 different ones and 3 different upgrade states right now in the game. You try to defend against the runners that your opponent sends to you, and the right combination of defenses against the right combination of attacks will lead to victory. When you send runners to your opponent, a little dropship is picking them up, sending them up to your opponent's stadium half, where they try to defend against them. There are 3 different armor types and damage types, and you have to figure out the right combination of towers and runners to win in the game. The game is built upon a collectible card system, which means that you have 4 towers and 4 runners in your deck, and before you're starting a duel, you select which ones you want to take into the duel right now. And also they are fully customizable via our level up system. Now onto the game development part on here. Since it's a multiplayer real-time game and it's on mobile, we have quite a lot of challenges to overcome here. And we're going to get into the details of all the pitfalls and issues you might have when you are trying to develop such a game on your own, and how to avoid them. The first big question you have to wonder about is, do you want to make a client-server system, or do you want to make a peer-to-peer game? There are many different approaches to tackle both, but this is the first and most important question. And for us, it was pretty easy to answer at this stage, because a client-server system is quite costly. So you have to maintain a server, you have to buy a server, you have to upload your builds there, so it takes also a lot of time, and you have to also develop a server at the same time. And it's not really that flexible, because you have to be sure that at all times you have enough server capacity for your clients to handle, and you have to rent a certain amount of server space to handle it. Therefore, we went for the peer-to-peer approach, which allows us to simply connect players. And at all times, if there are two players that want to play with each other, they can connect and play the game. There are other downsides of peer-to-peer, like not being able to have the full control of the game data and game stats at all time. But we have overcome them with a couple of clever design decisions and an anti-cheat system that allows our peer-to-peer system to be as effective as a classic server client system. Okay, so now that you've selected the way you want to build the game, you want to make a peer-to-peer game, you have to figure out how you're going to do that. And as most often in game development, you don't want to build something yourself from scratch, so you figure out which SDK are you going to use this time. At the time that we started to develop the game, there have been 3 big players in the peer-to-peer SDK market, which was Google Play Game Services, which was completely free but requires a login. Then Nextpeer, which is also completely free but required you to put their user interface in your game, and it also had a chat system included. And Photon Realtime, which was just really bare bone, right at the network level, and you are just sending packets around and it's handling the headache for you, basically. So we developed test apps for all 3 of these systems. And we benchmarked the latency. As you can see, Photon Realtime was far superior than any of the other SDKs. And what you can see here is the average round-trip time that we measured. So Google Play Game Services and Nextpeer even had spikes of like around 2 to 3 seconds at times, which is completely unbearable for any multiplayer gaming at all. So I can only give you the advice that anytime you select an SDK, you should really make a test app before, test it, and figure out how they really behave, because usually the advertised features don't work right as well out of the box as you would hope they would. So we've went with Photon Realtime, and we've been happy with that choice from then on. And it worked pretty well throughout the whole development process. Okay, so you know now your bare-bone network communication works via Photon Realtime, and you have a peer-to-peer connection between your clients. Now you have to decide, how are the clients going to communicate with each other, and how do you make sure that they are showing the same game at the same time at all times, and there are no disconnects and no further issues. Again, there are 2 choices. Either you select one client to be the virtual host in your scenario, and the virtual host sends all the data constantly to the other player, and you sync the game in this way. So one client calculates the full game, the other is a dumb client and just receives data, shows the towers and units where they are running, and doesn't know anything much about the game. But being on mobile, that is not really feasible, since you have to send a lot of data around, and people will use up their mobile data plans and be quite unhappy if you're sending huge amounts of data all the time. Imagine sending every tick, all data of all towers and units. It's going to be a lot of data, and people will be really unhappy. So we decided that we are going to go with the Lockstep Multiplayer, which means that clients are only sending their inputs to each other. So only when I'm building a tower or when I'm sending runners to my opponent, I'm telling them that I want to do this action now and only this. So basically, if I don't touch the screen, no network data will be sent at all. That means, though, that both clients need to calculate the full game at the same time, and they need to be sure that they both calculate the same game at the same time synchronously. Like our two jumpers here in the water, they need to be perfectly in sync. The major pitfalls here again are that you have to be really aware how that works and how you get that to work, since you need to be sure that all your data sources that you're using, like maps and sets and arrays, behave the same on all the platforms. And you can't bring any randomness into the game that is not seeded and is sure that both random generators that you're using on both machines will generate the same random results at the same time always. All your arrays, all the data in your arrays needs to be in the same order everywhere to make it fully work. And there needs to be done quite a bit of debugging ultimately and a bit of researching to figure out where are you not in sync right now. But that's only the easy part. The fun part appears when you try to connect iOS and Android with each other. Because iOS and Android behave in quite different ways, and since we are making the game in C++, there are different implementations of the C++ standard library on iOS and Android, which of course behave differently. So you have to read up in the iOS and Android C++ implementations to figure out how their maps and how their sets behave exactly, so you're only using the functions that are sure to behave the same. For example, you cannot use any unordered maps or unordered sets at all, since their interiors will be completely randomly ordered, and when you then iterate over them, you are getting random results depending on the platform. So therefore, our whole game only consists of ordered maps from the time on when we figured that out. And of course, the next fun part is that you need to get floating point calculations synced on both platforms. And of course, there is a relevant XKCD as there is for everything. Yeah, so floating point calculations are not that sure to result in the same end results when you are calculating things twice or like hundreds of times, even on the same machine. But iOS versus Android is a whole different problem, different processors on all kinds of devices, and especially the Android world features a lot of devices that behave in completely different ways. Therefore, we replaced all our floating point calculations with integer calculations. So we are using fixed int floats, which means that we have a special data type that emulates floating points with integer calculations. And integer calculations are safe to always result in the same calculation results in all platforms at all times on all processors. Therefore, no more desyncing issues due to floating points when going this way. Okay, so we now know how to connect clients, we know how to avoid getting out of sync with each other, and we know how to not burst up the mobile data plans of our players. Now we need to figure out how we connect them with each other and how our own network logic for the game works. So first of all, at the top, players receive the DAC of the other player after they connected on photon, and then one player is decided to be the virtual host and one the virtual client. But this doesn't mean that they send a lot of data around. This just means that we know who's responsible to keep up the connection and who is responsible to reconnect each other if something happens. So at first, the the host is telling the client when the game is about to start. So there is an external server timestamp coming from Photon that tells us which time it is right now, and both clients know this timing, and this time is sure that it's the same timestamp across all devices. So the host tells the client that from now on, in 3 seconds, the game is going to start, and then both are running down a countdown, also showing that countdown to players that the game is about to start right now. After the countdown is running down, the game is starting. We are in the playing phase. Players are exchanging their network commands that they send and receive all the time, and we are happily in the playing phase until there is a network desync or a disconnect, which could be both really. So that means that if one client doesn't receive a network command of the other in time, then of course the game is going to go out of sync and one is going to calculate something different than the other, or there is a straight up disconnect and we need to reconnect them. So in the state machine we are going to the connection issue state. Now again we have to resync the clients, and the host is going to tell the client at which point back in time they are going to go, where they are both aware that they still have the same game state. So this is usually something like 1 second in the past, and we only have a little lag. And then the host tells the client again when the game is going to restart. So when is the timestamp arrive that they are both starting the game again. And once they are both happily in the gaming state again, both have the same synchronous state, the game starts again. Until in the end, the game ends in a normal way and one player won, or any other network issues happening that we can't recover. For example, some client just shut off their device and they are gone for good, and then the other just won and the game ends. Now about how network commands are exchanged and how we optimized our game for the best performance. This diagram here is split into threads. So here's the main thread, and here's also the main thread, while here we have the simulation thread of the game. Simulation thread means that all calculations happen in the simulation thread. Basically tower shooting and runners moving and everything that is not related to graphics is running on the simulation thread. Then the input of the player and also the network commands that they send and that come are also on the main thread. Therefore, we don't need to do any syncing between the main thread and the network thread, which is a good thing, and they both also do not need that extensive resources. Now, if a player sends input up here, it's going to be transformed into a command, a little command object with few data, or like a few bytes only. It is sent to the network thread, so to the network, to Photon real time over the network on the same thread, so no syncing. And it is put into a concurrent queue here, so the simulation thread knows about it. Concurrent queues have the benefit that one thread can input data, while another thread can read the data, and you do not need to do any stopping or like any syncing between the threads, which means that your game doesn't waste any performance or doesn't stop or lag at certain points. Okay, so those network commands that we are dealing with are now here in the concurrent queue, and they are sent over the network. And also the commands that the opponent sends us are received from the network and put into the same concurrent queue. This means that the simulation thread is now reading from that concurrent queue to know about all the things that are happening with the game. Any towers are built or any runners are sent. But first of all, before they can be executed, they are validated. So we check, is this command valid? Is the opponent trying to cheat? And also, really interesting, that we are basically testing our whole user interface with that validation as well. So if our user interface would allow the player to spend more money than they have or build at any points that they wouldn't be allowed to, our validation in the simulation, so our anti-cheat system, is also a great help for debugging the game. Okay, so commands are validated yet, and now they are pre-processed. The pre-processing is needed because the commands are scheduled into the future. This means that if I tell the game now that I want to build a tower, this command is only going to be executed from now on in 2 seconds. This is to avoid any network delay, so the game can handle network delay of up to 2 seconds, or any value that you want to set for your game that your game can handle, obviously. So all these commands in the queue are going to be executed in 2 seconds, are validated, and are now pre-processed before they are executed at all. And in this pre-processing state, the game figures out which of these commands are going to be relevant for the graphics. If the opponent or the local player wants to build a tower in 1 second or 1.5 seconds, depending on when the network command arrives, we still want to show the graphics immediately and want to update our graphics right now to show that this tower is going to be built there. We want to show the building animation. So the pre-processing takes care of that and figures out all the necessary updates that the graphics needs. So between the networking thread here, the simulation thread here, and the graphics, here is also a concurrent queue again. And all these updates here are also, again, little update objects for any action that happens in the game. For example, there is an update object for a tower just shot, or 1 unit was destroyed, or a player lost the health. So there are around 50 different update objects that handle different graphic changes in the game. And those update objects are then here split again, and split into around 50 functions, and every of these little functions then has to only do little work, which is the classic divide and conquer principle, to avoid that any function that alone has to figure out all the different graphics changes, and it's all really chunked up into small pieces. Okay, so one step back. We are getting a network command from the opponent. It's getting into the queue, it's validated, it's pre-processed. And now, after the 2 seconds passed, we're getting into the execution phase. Again, now the tower is really built. Only now it's built. Before it was only shown on the network thread and on the main thread that it's going to be built in the future. But now the simulation for the first time builds it. Before, it didn't really know about it at all. And it also didn't do any actions due to the tower. And of course, since it's executed now, we are also sending updates to the graphic thread that the tower building is done. The tower is now completely finished and shown on the playfield, and players can touch it and upgrade it or do different actions with it. And in the following ticks, the tower is going to be taken into account. So it now starts to rotate and to shoot and to fire and all these things that it needs to do according to the simulation. Are there any questions about the user interface and main thread versus simulation thread splitting? Everybody happy? Okay. Great. So we figured out how we do the threading, how we save a lot of performance on our mobile devices, and how we use the multiple cores of these devices. We connected the players, we built our simulation, and now we need to debug the game. We need to figure out, are those two clients really in sync at all times? So what you see here is a really old screenshot of TowerDuel, like around 2 years ago. It looked like this. And at the top here, you see the hash value that represents the whole game state. That means that every couple of seconds, the whole game state is being serialized and transformed into a hash value, and that hash value is then compared across devices. And at the beginning, we just sat there with 2 devices and looked at the screen And we've been happy if the hash value was identical and our clients were connected and they could play nicely. But by now the system matured and it's all happening automatically under the roof, and automatic reconnects and rollbacks are happening if necessary. Okay, the networked design is working, but our game also needs towers and units to work with. That means that you have to program a lot of towers and units into the game, and you also have to create a system that allows you to create new ones really quickly. In our case, we decided for an entity component system, which means that all towers and all runners in the game are split into smaller components that can be mixed and matched as we want to. Here you see our chosen design approach, or our chosen data input approach, which is an Excel table, like a small chunk of our Excel table. And for our rocket tower here, you can see that it has an apply hit entity detector component, which means that this detector is a physics check. It checks in a circle if the rockets that this tower is firing hit anything. And in this way we can also easily change the radius, how it works, or we can also change it to a vastly different detection system. So we could enter a triangle component in here that detects if the rockets are hitting something in a triangle, if we want to make a triangle rocket tower. Or we could make a tower that is shooting rockets, but when the rockets hit the target, they are shooting lasers in 4 directions. And then this detector here would be something that detects long lines in 4 different directions upon hits. Another example here is the piercing tower that also detects its hits in a circle, but a smaller circle. So it's shooting projectiles, and the projectiles are circular and they check if they hit anything. But after that hit is detected, it also does a selection step, which is a different component down here. This component is named multiple one strict, which means that this tower with only one projectile can hit multiple targets. Since it's a piercing tower, it shoots through units and can hit up to 5 or 6 units. But it only allows the hit on the same thing once, and it's strict about it. So even if it doesn't have any other options, it will only hit the same unit once and not any more after that. So if it flies through one unit and it hit it once, even if in the next tick another hit on that unit would be detected, it is completely ignoring that hit. And the last example in the tower design component thing is the shotgun tower, which is shooting in an arc, so in a small cone with an angle width of 35 degrees and a quite large radius. So it's a classic shotgun tower that is effective at smaller distances. But it's not that accurate. So after it detected which units it wants to hit, it's doing a selection step where it one by one, so for every runner on its own, checks with a certain chance if it will hit it. Since it's a shotgun tower, it has a huge spread, and there is only a certain chance it will hit anything. Here's an overview of our whole tower component system, how a tower is going to figure out if it will hit anything. Right at the beginning, in the top left, we see the first entity detector step. At this step, the tower looks around itself to figure out if it can see any units at all that it wants to target. And even at that step, you could design it that way that it's not a circle, but maybe it's looking in a triangle, or it's looking only in the 4 directions around it, which units it wants to see at all. The next steps, there are multiple selectors that can be chained to figure out which ones it wants to hit. So now it knows which ones it can hit, but which ones does it actually want to target. There could be a tower that only shoots at the unit with the highest health around, or most towers want to shoot at the unit that is closest to it, to the next exit, as in most tower defense games. After it figured out a unit that it now wants to shoot at, it checks if it's reloaded here, and then it checks if it triggers its firing. And after it decides that it now triggers to fire, it fires here, and there are different options how it can fire. Either it deals the damage instantly, like a laser tower, or it fires a projectile. Then the projectile movement component takes over and decides how the projectile moves. So projectiles could move in waves, or they could move really slowly, or they could split mid-air and do something different. They might follow the target and be homing, or they just shoot at a certain point at the ground, and wherever the tower decided to shoot then, it will end up at the spot. The projectile tries to trigger its hit if it's close to the target or it directly hit the target. And once it does so, certain events might be triggered. Those events can be quite arbitrary. For example, it could be that once this projectile hits anything, there might be an EMP strike and towers around it might be paralyzed for a certain time. So those events here are basically arbitrary actions that happen at some points. Or the tower fires instant, and then here we need another entity detector to define the area in which it detects its hit. So it might look around it in a circle if it's a laser tower, and then the detector here is a line detector to shoot at things in a line, and the selectors again can decide which things it actually wants to hit and will hit. In the end, we apply the hit again with certain on-event triggers, which could add status effects to the units. A slow tower shoots at the units, hits them, doesn't do any damage, but applies status effects on them, and then they will be slowed for a certain time. Additionally to the whole combat mechanics, there is also the pre-update phase, where before the actual update happens, the tower can do certain actions, and the status effect manager that ticks the tower's status effects that are currently active. For example, it might be on a frenzy and have a higher fire rate right now for the next 20 seconds, and then the status effect manager ticks that down, as well as the pre-update manager who's doing several other actions. For example, checking if the tower has its active ability ready and updating certain other stats on the tower that need to be done every tick, but before all the combat things happen. And in the end, there's also an active ability for the towers, so certain towers can have abilities. If you double tap them, then they might explode, or they might get into the firing frenzy and shoot really quickly and get a status effect. So all different things are possible with the active abilities. There are also different components. So that means that with the system, you are able to design a vast amount of different tower combinations just by defining all these single components, and all these single components you have to program at some time. But once you have them, you can mix them and match them as you wish and just enter different values in our Excel table, and you made a new tower. So for many tower designs, especially in the prototyping phase, you don't really need to touch any code at all. You just enter new values into the design table, mix and match certain components, and you have a new tower for testing ready. Okay, so thanks everybody for listening. If you're interested in any university projects, bachelor, master thesis projects, internships, or if it's only becoming the world champion of TowerDuel, we invite you all for that. Contact us, join our Discord channel, join the community, discuss the game with us, and we're happy to hear from you all. Yeah.
Please make sure that you can see this microphone right here. If not, people will not understand you.
I can see it.
While speaking in it.
Okay, okay. Does this work? Fantastic. Okay, so you're going for a peer-to-peer approach,
Yes.
but doesn't that make it easier for, let's say, malicious third parties to exploit vulnerabilities because you don't have this central server that ensures a valid state?
What things do you mean especially? Like, what do you think could happen?
Like, are you storing the elo and the rank and everything locally?
No, we have a data warehouse server where all the data is stored and the player data is also safe on the server. And to make sure that nobody can fake their elo, players report their match results after the game, and we have an anti-cheat system that makes sure that the match results match. And also, like, both players reporting the same things after the match. If both players report different results after the game, then it's sure that one tried to cheat or did something malicious. And we have also certain other anti-cheat systems that I can't go into much detail.
So, but in that case, what prevents people from setting up two Android VMs with the app and just sending details to the server that they both have won, lost, whatever?
Well, first of all, to play against each other, you have to be matched online. So you can't force yourself to be matched. And if we detect that anybody is trying to do something like that, they're getting a negative score internally, so a negative anti-cheat score. And if their anti-cheat score is too low, we are going to investigate on this issue and take further actions to prevent it from happening.
Cool, thank you.
You're welcome.
Hi, thanks for being here. How successful is your game currently?
We have 50,000 downloads right now, and we are still in the progress of optimizing the game and getting more and more downloads and more Apple features. And yeah, we managed to get these Apple features initially, which was a great boost for us. So it's a cool thing to always try to contact Apple and Google to get those features and get more people to test. And the community we have is growing daily, and they're giving us constant feedback, which is also super awesome for us. So we are really happy. We are at this stage right now where we're getting all the feedback, and once we are doing updates, we're getting new info about how the players think it works, and they're testing our balancing and the new features immediately.
Okay, and because your game is free to play,
Yes.
I assume you have in-game things you can buy in-game, right?
Yes, exactly. So we have the classic approach that you purchase in-game currency, and with that currency you can do certain actions. One of these actions is to do further customizations of your card. So if you selected a customization once, you can then re-roll the customizations to dive into different options, to customize your deck further. And you can also buy booster packs, which are saves in our game, to get more cards and to progress quickly.
How's that approach working for you?
Well, it's the best approach that there is, and it's working well for us. And we're happy we chose this approach, because as a mobile game nowadays, there is no really other way to go than free to play. We are getting a lot of players this way, and the game is growing, and we need a lot of players. We need a huge player base for multiplayer real time. So the more players we have, the better for us. Free to play is the best option that there is, and we didn't regret it at any time. We are happy with it.
Thank you.
Yeah.
Because we just had the topic of player bases,
Yeah.
what's the average waiting time for a match?
The average waiting time is around 10 to 15 seconds.
component system that you described for
Yep.
configuring your towers, did you do it very generically, very broad in terms of your project, or were you focusing only on the design of the towers?
Well, we built a generic entity component system that could be used in any game, but the components that we built then are quite TowerDuel focused, because we need tower combat components, and we need components that make sure that the tower looks around itself and starts to fire. But for example, those entity detectors and entity selector things that we have there, they are basically just doing collision detection and selecting which entities to target. So they're really generic and could be used in any context.
So follow up on the economic side. Now that you have all this technology base, you are perfectly ramped up and set up for producing a new game. Is there anything on the radar, or is your goal to boost TowerDuel for the next 3 years and grow a massive user base of millions of people? What's your take on that?
Our focus for the immediate future is definitely to focus on TowerDuel, to boost it, to develop further features and make it the greatest game it can be. There's still a lot of features that we have to dive into and that are still in development. We want to work on. We are still in need of a competitive mode where people can compete, like in a draft setting, for example, or where there are events and people can have different types of game modes. And we also need to add further cards and content so players can dive into more tactics and have just more things to play with. So we still see a lot of potential in TowerDuel. That's why we fully focus on that right now.
So all your milestones for the near future are basically sketched out like what you just said. You have specific milestones
Yes,
for
yes.
introducing events, for instance.
For example, yes.
Yeah. Cool.
So why didn't you use some established engines like Unity or Unreal?
Good that you ask. I got some slides about that. I also got a meme slide, obviously. But maybe more of that later. When we started TowerDuel, there were 3 big engines, and like we selected a development SDK for network games, we did the same thing for game engines. So we figured out that the popular game engines, at least 2 years ago, weren't really suited for a mobile game in 2D that needs a lot of sprites rendered at the same time, and where are lots of units and actions and explosions happening. We created a basic test project for the Cocos 2DX engine, where our highly modified FRG engine is based on now, and Unity 5 and Unreal Engine 4. Both Unity and Unreal back then had already a basic 2D features. And in these test apps, we spawned sprites on the screen, moved them in random orders, and animated a basic PNG sequence over them. And the test is, how many sprites can we render before the engine lowers their FPS? So how many sprites are there that the engine can handle with certain devices? So you see here on an iPhone 6s, we could render around 500 sprites, both on Unity and Unreal, before they start to really go down in performance, and where it slowly starts to get unbearable for the player and starts lagging, while the engine we choose doesn't lag at all and doesn't have any of these issues. Same test with an iPhone 4s. That was when we started still in the life cycle of Apple products. And here it was even more drastic, and the Unreal Engine could barely render 20 sprites, while the Unity engine was able to render around 300 sprites. Due to those performance reasons, we went with the approach of not using Unity or Unreal here.
Do you consider continuing with a new game, or are you still planning to further improve this one?
I answered the question before, but please feel free to ask it one more time.
We're going to further develop on this game.
Any more repetitions? maybe some innovative new game questions. Jonas.
So my question is a little bit more about starting your company. You said you did major work already while studying.
Yes.
So how was the step from university to founding this company and then releasing the game?
Okay, so I worked on the prototype of the game during my master thesis. Once the master thesis was done, the prototype was ready, but it wasn't fleshed out to be released as a game yet. So it was playable, and you could compete and play with two devices, and the technical sides were fine. There needed to be done a lot of polishing still and figuring out how the app stores work and how company funding works. Therefore, we applied for the Exist fund back then, and we were happy to also be granted with it. So we had 1 year of the Exist fund where we had more time to develop the game, found the company also then, because you're not allowed to already found the company when you apply for the Exist fund. So if you want to approach this way, you have to be really careful that you choose the right scholarships at the right time, because if you do things in the wrong order, certain doors close and others open up. And with this approach, it worked out for us.
I've got a question about the matchmaking. Is it locked by region or is it international?
It's international.
But the latency latency say, a player from Germany and a player from the US, it's still manageable.
Yes, the game can manage a network delay of up to 2 seconds if necessary. So we can do matchmaking worldwide. Basically, it's the thing about the commands being scheduled in the future that we had earlier in the talk. So if you are now in the US and you tell somebody from the other end of the world that you want to build a tower now, the command has up to 2 seconds to arrive at this player's device, and then it's still going to work fine. Since commands are scheduled in the future and it's not immediately necessary to be there in 100 milliseconds or so, which is nearly impossible on mobile anyway.
How does one get featured in the Apple Store or the Google Play Store? Do you have to ask before publishing and prove that you are worthy to be published?
There are multiple approaches here. You can directly contact Apple and send them a request to be featured. Bigger publishers have a direct contact with Apple, so some person that they can speak to and pitch in front of them to have their game featured there.
Just asking, are you planning on like region locking in order to achieve a smaller delay, like that you go down to 1 second instead of 2 seconds, or will you just like keep with it or try to go further down without region locking it?
We're not planning to do any region locking, especially since on mobile there can be lag spikes of 500 milliseconds to 1 second anyway, and this is a much bigger impact than the region you're in right now. So if you are playing in the US or if you're playing in Germany with somebody from Germany, doesn't matter as much as if the connection of the other guy is great. So if they are on Edge or 3G only, you might have lags anyway that you can't prevent much. Also, the lags in our game don't matter that much. You don't feel them at all. The game is designed in a way that all actions have a certain time to be executed. So tower building takes a bit of time. If you send runners to your opponent, a spaceship takes off the unit and flies over. So anything intentionally was crafted so that this network delay is inside the game design itself. And it's not an issue at all. It's more a feature really at this point.
Okay.
So each action does need at least 2 seconds in your game?
Well, it doesn't need to. You could reduce the timer as much as you want to, and if you play locally, you can also have less delay. But yeah, the general events that you actions that you take 2 seconds until they are applied. Tower building has a building time of even 3 seconds. So even if we could do it quicker, we decided that for game design reasons, it makes sense that towers need a certain time to build. We need to show the building animation and show the player that this thing is now built on their grid. And the dropships that fly over have a flight time of around 1.5 seconds.
Is there a Bluetooth possibility to play the game?
No, we don't plan on any Bluetooth thing because basically Photon Realtime doesn't support it, and not that many people would like to use it at all. And playing over the normal internet is usually just as fine as that.
Okay.
How many players exactly do you have active at the moment? Not at the moment, but like just active. How many players do you have on average?
Unfortunately, we can't tell the exact numbers of active players from the day-to-day basis, but it's definitely enough so that anybody can find a match or play at any time.
In which time you bring new features to the game? So do you have, for example, every month there's a new update and there are some cool features, or how do you do it? How do you balance maybe the game in a season, for example?
Usually we are updating weekly. If there is not a bigger feature that takes a longer time to develop and it wouldn't make sense to make an update earlier. But for smaller iterative changes, there are weekly updates, and also changing the balancing is really easy since everything is based on that entity component system and a huge Excel table. We can simply upload balancing changes to the server, then the clients download it and the balancing change is done. So that can be done really, really quickly. Yes.
I'd like to ask if you are planning to do a friend-to-friend connection so you can play against the person you know, or if you just, first play at the exact same second, so you're hoping that the matchmaking matches you together?
That's already possible and already in the game. The game features a full friend list. You can add your friends, and you can then play against them. Also, if you invite new players that haven't played the game before, we have a referral system in the game that gives you certain benefits the more people you referred. Yeah.
How much and how do we involve the community?
Community is involved in most aspects of the game development. We ask them in Discord for their opinion on certain new features, and they constantly give us feedback on everything. So before doing a big update, we upload it to a beta branch. From that beta branch, they are testing new features, reporting issues, reporting how the balancing works. They usually also do extensive balancing tests, which is awesome. And thanks to you out there, you're awesome. So we are super glad we have these people, and they help us a lot in the development process.
Cool. More questions?
So you don't have local playtesting. You only push this beta branch or whatever, and then let the community test, or do you have local testers?
Well, we also test on our own. During the process, we create a new build, upload it internally, then the team is testing it first, and once initial test with the team work, we upload it into the beta, and then it goes live.
Okay. Slightly off topic, but how skilled is your team compared to your best players?
Well, I'm pretty sure that our best players would destroy any of our team, frankly. Though we are still able to somewhat compete. We once did a tournament against players and played like a session of different matches, and against like the top of the world, we are still able to win a small percentage of games against them.
Well, and a question on the player base. Do you have any data on where the majority of your players come from, or is this completely unknown?
The majority of our players comes from Germany and the UK right now, because we had the biggest featurings in those countries from Apple, and therefore a lot of players came in via that stream. And we also have English and German localizations in the game so far. So it's the natural order of things that where you localize the game, that you're also getting lots of players, and players are much happier when the game is in their own language.
Okay, maybe one last question, maybe. If you guys are satisfied. So regarding localization, which languages are you currently working on?
We aren't working on any additional localization languages right now, because localizing the game takes a lot of time, and you are putting also a lot of future work on your back. So if you develop a new feature and you want to test the feature first, or you want to test certain other aspects, you need to localize every single piece at all times. So first of all, we are going to optimize the game, build in further features, and then once we are happy with the current state, then go into the localization stage, where we localize further languages that we do not have on the team and can't localize easily ourselves.
I'm very much looking forward to this, because then your user download rates and everything might actually skyrocket at some point, right? Because if you go into a new market like China or Southern America or whatever, then the potential is enormous, right?
Yes.
Well, since I called it out to be the last question, and I don't see any fingers rising up.
Do you think about the Chinese market?
Yes, we thought about the Chinese market, and also we had a couple of players from China, but since there's the Great Firewall in place, China is a special case, and you have to do a lot of work to get China out in your game. Also, there's legal trouble in China, and your games have to go through a process where it's going to be accepted by the government or certain other rules there. From all we've heard so far, the best approach to go to China at some point is with a publisher.
Well, that being said, thanks again for coming. It was a great pleasure having you.
Thanks for having me.
Thank you, everybody, for tuning in and also for your questions here at the University of Würzburg. And with that, I would like to close the session, and I would want to welcome our guests and online and locally also for the streaming session on the 4th of February. And that being said, thanks to everyone and have a good day.